Next lesson is called slope-intercept form, and it's pretty much what this whole unit's been building towards, an ability for us to put lines in a form which we can then quickly graph. So we're going to use slope-intercept form to identify the slope and y-intercept of the line from things that are already put into slope-intercept form for us. We're going to learn how to write an equation in slope-intercept form. We're going to use the slope and y-intercept to graph an equation, and then we're going to be able to recognize parallel and perpendicular lines from their equations in slope-intercept form. So, first thing we're going to do is we're going to look at a graph. The graph of y equals negative 2/3 x plus 4 is shown in the figure, and enables us to see that the slope of the line is negative 2/3 and that the y-intercept is 0, 4. So basically they showed that if we take this line that they've given us and we plug in some points, they put in 0 for x, that got them 4 for y. They put in 3 for x, that got them 2 for y. So after plugging in these points for x, getting back a y value, they plotted the 2 points, 0, 4 and 3, 2. Doing rise over run, they saw that it went down 2, so a rise of negative 2 on top of the fraction, and over 3, a run of positive 3. So, doing rise over run, they see that negative 2/3 is the slope. Similarly, if they want to find the y-intercept, what that really means is, where does the line cross this up and down axis? Well, where it crosses is at this point right here, 0, 4 that we found. So, what they're showing us is from this original form of the equation, if we do out all this work, then we find that the slope is negative 2/3, and we find that the y-intercept is 0, 4. But really, we could have gotten that right from the equation of the line. When you look at the equation of a line that's solved for y, whatever number is being multiplied by x is the slope. Whatever number comes after the x is the y-intercept, given that the x value of the y-intercept point is 0. So 0, comma, whatever this is, in this case a positive 4, is my intercept. Whatever's in front of the x is my slope. So this was just an exercise showing you that yes, this is true. So from the equation and the graph, we can make 2 observations. It crosses the y-axis at 4, where this positive 4 is the y-intercept. It moves negative 2 to rise, 3 run, or this negative 2/3 is the slope. In the general form of the line, y equals mx plus b. This m thing multiplied by the x is my slope. This b thing that's after the x is my intercept. So if a linear equation is written in the form y equals mx plus b, then the graph of the equation is a line with slope n and y-intercept 0, comma b. So find the slope and y-intercept of the graph of each equation. First one, not so bad. Here it has y equals, I see in front of the x is a 6, so I'd write m equals 6, or slope equals 6 for this one. I see after the 6 is a negative 2, so I'd write b equals negative 2, because b stands for the y-intercept. Or if I wanted to write it as a point, I'd write parentheses, 0, comma, negative 2, and parentheses. For b, pulling out the slope isn't so bad. Here's that negative 5/4 being multiplied by the x. So m equals negative 5 over 4, or slope equals negative 5/4. Little trickier when I go to find the intercept. I don't see anything here. If I don't see anything here, that doesn't mean there isn't an intercept. What's really happening is I'm technically adding 0. If it's not there, 0 is what's being added. So if I want to find my value for b, 0 is the value for b, which means that the point for the y-intercept is 0, comma 0. For the last one, y equals x over 2 plus 6. In this case, I'm going to start at the intercept because that one's more straightforward. This plus 6 is telling me the intercept's occurring at 0, comma 6. So b in this case equals 6. For this x over 2, it's a little trickier. I don't see what's being multiplied by my x. Really, I need to understand that this is 1x over 2, and that I can pull that fraction 1/2 out in front. I can then call this 1 over 2 times x. If I do it that way, then I can see that 1 over 2 is the slope, or 1/2 is my m. So let's walk through these. We're going to write them each in slope-intercept form. Here they've made purple the slope, they've made blue the intercept. So they get m equals 6 and b equals -2, or in other words, the y-intercept is 0, -2. For the next one, they get -5/4 in front of the x as the slope, and there's an understood +0, which is the y-intercept. So the y-intercept is 0, 0. For the last one, x over 2 really means 1/2 x. So I can rewrite this as 1/2 x plus 6, meaning in purple the 1/2 is the slope, and in blue the 6 is the intercept. That's why I get 0, 6 if I'm writing the point for the y-intercept. Write a linear equation in slope-intercept form. The equation of any non-vertical line can be written in slope-intercept form. To do so, we apply the properties of equality to solve the equation for y. So if we want to find the slope and y-intercept of the line given by this equation, what that really is telling me to do is solve for 1y. If I get the equation in terms of y on the left-hand side, then on the right-hand side, whatever number is being multiplied by x will be my slope, and whatever number is being added or subtracted to x is going to end up being my y-intercept. So, first thing I need to move is this 6x. In order to move that 6x, I'm going to have to subtract 6x from both sides. So the positive 6x that used to be here, when I subtract 6x, it goes away. What I do to the left, I have to do to the right side of the equation. When I subtract 6x over here, I'm left with minus 6x plus 9, because 9 and 6x are not like terms and cannot be combined. I'm now at the point where I say, well, what's happening to y? It's currently being multiplied by -3. So if I divide each term by -3, that'll get me to positive 1y. So this is showing that I'm going to divide each term by -3. -3 divided by -3 cancels and just leaves me with y. -6 divided by -3 gives me a positive 2. And 9 divided by -3 gives me a -3. That leaves me with the equation y equals 2x minus 3. Now, since I have y alone on the left-hand side, I've got something multiplied by the x, and I've got a number being added or subtracted. It's in the proper form to pull out the slope and intercept. The slope is what's in front of the x, so the slope here is 2. The intercept is what's after the x, so the intercept here is -3 as my value for b, or in other words, as a point, the intercept is 0, -3. Use the slope and y-intercept to graph a linear equation. If we're asked to graph y equals 2x minus 3, where you start comes after the x. This -3 means I start 1, 2, 3 down, and that point 0, -3 is going to be my beginning point on the axis. From there, I need to know how to move. So I look in front of my x to see what the slope is to tell me how to move. That 2 is really an understood 2 over 1, meaning I need to rise 2 as I go right 1. From this point 0, -3, I rise 2, and I go right 1. That gets me to the point 1, -1, which is another point on the line. If I wanted to do it again, I could rise 2, go to the right, run 1. That would get me to the point 2, 1, also a point on the line. But really, as long as you do it once, find your starting point on the y-axis, find how to rise and run from there to find the second point. Those 2 points are enough to determine your line. If we begin at 0, -3 and move up 2 units for the rise, and then to the right 1 for the run, we get to the next point 1, -1, which is the second point on the line. Draw a line through it, and then we've completed the task of graphing the line. To recognize parallel and perpendicular lines, basically if we're looking at their equations, we want to look in front of the x. We want to look for one of 2 things. Either what's being multiplied by x is the same, meaning I have parallel lines, or what's being multiplied by x is negative reciprocals, meaning I have perpendicular lines. In this case, we're given the lines y equals -2/3 x and y equals -2/3 x plus 3. When I look what's in front of the x, in the first line it's -2/3. In the second line it's also -2/3. Since the slope is the same in both lines, these would be an example of parallel lines. So if we're going to find the slope of each line, for the first line the slope is negative 2/3. For the second line the slope is negative 2/3. For that reason, the same slopes means that the lines are parallel. If I had gotten negative 2/3 here and positive 3/2 here, negative 2/3 times positive 3/2 would give me negative 1, which would mean I'd say they're perpendicular lines. If they're not exactly the same and they don't multiply to give me negative 1, then I would say neither is the correct answer.